Here's number 24 from the 2012 AP Calc AB multiple choice set. Non-calculator question gives us this function g of x. Now the weird thing about g of x is that it's got this k up in this exponent here, and that value is not specified for us. It goes on to ask us to figure out for what value of k does this function have a critical point at x equals 2/3. So a critical point or a critical number is any value that's going to be within the domain of the function that makes the derivative equal to 0 or makes the derivative undefined. This function is pretty nice the way that it's composed here. It's just a product of two pieces that are always going to be defined. The function is continuous. The derivative is likely also to be continuous. Not guaranteed, but that is extremely likely. If we think about taking this derivative, we're going to have to use a product rule, right? X squared times e to the kx. So I do the derivative of the first piece, the original second piece, plus the original first piece. Here's the derivative of the second piece. The thing you have to watch out for here is when you take the derivative of e to the kx, you have to use a chain rule and multiply by the derivative of the inner function that sits in that exponent to finish it off. If you analyze this derivative real fast, it doesn't involve any division or anything that would lead us to worry about being undefined. So we don't really have to worry about this in this particular problem. We're going to be looking for a place where the derivative is equal to 0. And so I set the derivative equal to 0, kind of cleaned it up a little bit along the way, just kind of reshuffled how that second term was written. And I looked at this equation and I thought, man, this is kind of goofy because I've got x, I've got e to the x terms. I've got this k that I'm trying to deal with. I do have it set equal to 0, and I am always going to try to solve an equation by factoring when it's set equal to 0 and I'm not using my calculator. It's not guaranteed that that's going to work, but it's usually going to work within most of these problems. So I do have a common factor of x shared between these two terms. I do have a common factor of e to the kx shared between them. So if you factor out x e to the kx, you end up with this result across this line here, right? So removing x e to the kx from this term leaves us with 2. Removing it from this term leaves us with a k and one of the x's remaining. Now I have a three-part multiplication problem. Answer to that multiplication problem is 0. When is this piece going to equal 0? Well, only when x is equal to 0. But we're told that we're supposed to have the x value of 2/3. So this doesn't really impact us for what we're trying to figure out within this particular problem. When I take e to the kx and I set it equal to 0, I'm not going to get a solution from that because e to a power is always positive. It's never 0. It's never negative. So I don't really have to worry about that. So the one piece that I have to worry about is this piece right here. So I set this piece equal to 0. At the same time, I'm going to put the x value where I want the critical number to occur in for x. So basically, it comes down to solving the equation 0 equals 2 plus 2/3 k. So if you subtract the 2/3 k and then go ahead and multiply by the reciprocal or divide by negative 2/3, you end up with the result of A.